Okay, this is just an overview of part one, a few parts of our linear regression section. I just want to review the guidelines on what I'm expecting or what the course expects for linear regression. There are essentially 8 items that you might be asked on a test or quiz about linear regression. Number 1, identify the predictor and response variables. Let me get my pen going here. There you go. Predictor being the x variable, and the response being the y variable. And again, the response is what you're trying to predict. Use StatCrunch to obtain a scatter plot. Now, I will do that. The scatter plot will be given to you on a test or quiz. And then interpret the scatter plot. Identify or conduct a hypothesis test to determine whether the response is linearly related to the predictor variable. Is there a relationship between predictor and response? If so, we can make a prediction. Then use StatCrunch to identify the least squares of the regression line, regression equation, and interpret the slope and the intercept. Slope is definitely for each problem, intercept possibly, depending on the context of the problem. And I think that's going to get us through our first video. There are a few other parts, and if time allows, I'll have another video for you. I thought what I would start off with is just a problem. And this is a problem. It was drawn from a pretty good textbook that had, this was a project within that textbook of real data and a real problem. La Quinta is a hotel chain, and they launched a campaign to increase market share by building new inns several years ago. The management of the company selects the locations, and they'd like to predict what sites are going to be the most profitable in their opinion. So this is let me get my pen again. What they're trying to do is use regression to determine which site is going to be the most profitable. To do that, what they do is they look at a variety of things. The response variable, what they're trying to predict, is something called operating margin, and there's a technical definition of that. The ratio of the sum of profit, depreciation, interest expenses divided by total revenue, essentially operating margin for the hotel location. The higher the operating margin, the more successful, the more profitable the inn will be. Management is considering a number of possible variables, which is often the case. This is actually a multiple regression problem because there's lots of different possible predictor variables, things that could potentially impact profit. We're not going to look at all of those, obviously. In a multiple regression model, you look at all of those at once. What we're going to do is look at this one at a time. We're going to compare operating margin to, say, one of these. I always like to ask people, what's one of these variables that you think might affect operating margin? I think one of the things is the number of hotel rooms, competitors, if you will, within 3 miles of the location. So it's possible that if there's more hotel rooms, that's going to affect your profit margin. The data are included in this hotel location file. It's posted on our Blackboard site. And I have that pulled up in StatCrunch. Let me go to it. Here's the data. I'm going to conduct a linear regression, so go to Stat, and it's Regression, Simple Linear, and I have to identify the variables. In this spreadsheet, the y variable, that's the response, is the operating margin. The x variables are what you're going to try to predict the operating margin with, and what we decided, or at least I decided here, is the number of hotel rooms within 3 miles of this potential location. So we're going to try to relate, see if we can come up with a regression model of these. Alright, so all I need to do is compute, and I get a printout, which you'll see on your tests and quizzes. And I'm going to go to the screen. It looks like, okay, something's happening, that as the number of hotel rooms increases, the operating margin decreases. All right. So let's get back to the questions of interest. Excuse me, I'm going to get out of here real quick. And I'm going to look at a graph just of the data itself without the regression model. I do have the regression model, but a graph, and that is a scatter plot, again, of the operating margins, what you're trying to predict. What you're predicting with is the number of hotel rooms within 3 miles. Here is my histogram. All right. So now let's get back to the questions, which are questions you'll have to answer on a test or quiz from these regression guidelines. So I've created a few new slides so we can fill them in for this problem. First problem, which you may be asked, identify the predictor and response variables. In this case, let me go to get my pen, and let's go there. Is the response, I think, is the easiest, is the operating margin at the location. And the predictor, which is what we're trying to predict with, what we're trying to use to predict operating margin, is the number of hotel rooms within 3 miles of the location. That would be, in my mind, that's a measure of the competition, if you will. Next question you may be asked is use StatCrunch to obtain a scatter plot, which I just showed you a minute ago, and interpret the scatter plot. Now remember, there's 3 things I want you to do it with interpretation. Identify the general shape, linear or nonlinear. Is it a positive or negative relationship between the variables? And then obtain a measure of strength. Okay, and strength we said is measured by correlation. So let's go back to our. Actually, I'm going to get out of here real quick and go to the StatCrunch results, the regression results rather. The correlation between these variables is negative, which indicates a negative relationship, negative 0.47. All right, so what we have is we have let me go back to my PowerPoint. There it is. What we had is we had a relationship that had a negative correlation. So there is a negative. Okay, I'll just write a sentence. There is a negative, and we said it looks fairly linear. Let me take a look at that scatter plot again. When I say linear, what I mean is that basically, sorry, you can't do that. All right. Get off there. Deselect that. What you have is you've got a relationship. It's a fairly constant decline. It's not like speeding up or slowing down. It's fairly constant. So there's a negative, and I think it's a linear. And the correlation is negative 0.47, so that is moderately strong. And relationship between operating margin and number of nearby hotel rooms. Getting back to, I'm going to get another color here. When I said moderately strong, remember the way you do that, the way you determine that, if the correlation is essentially between 0.1 and 0.4, we're going to call it a weak relationship. 0.4 to 0.7, we're going to call it moderately strong or moderate. And lastly, 0.7 to 1 We're going to call that a strong relationship. Okay, so this had a correlation of negative 0.47, so that would be a moderately strong relationship. Okay, let's take a look at the third item. It says, is the response variable linearly related to the predictor variable? For that question, we need to go back to StatCrunch, and let me get out of the scatter plot and get back into, just get off here. I think I'd escape maybe. I'm not sure how I get rid of that, but we'll figure it out. Anyways, get back to the linear regression. Okay, and what we're doing is we are conducting a relationship to this, we're conducting a hypothesis test rather, to determine if the relationship between these variables, number of hotel rooms and operating margin, is truly exists. Is there really a relationship? And we talked in class that's really a question about the slope of this regression line. No relationship would mean the slope is not significantly different than zero. A zero slope means you really can't make any accurate predictions about one variable based on the other. So do we have a slope that is essentially non-zero? Now, so the question is, let me go back to my pen, is we'll say our null hypothesis is that there is a relationship. I don't think I write it quite as good as Sal Khan, by the way. I need to do a little work there before I can compete with him. There is a relationship between operating margin and number of nearby hotel rooms. And excuse me, there is, as the null hypothesis, I almost made a mistake there. It's a good thing I didn't. There is, cross that out, there is no relationship. Remember, the null hypothesis is a skeptic's hypothesis. We're going to say, nothing to see here, there's no relationship. HA is then that there is a relationship. And just in the interest of time, between ... so you don't need to rewrite it. Decision rule is reject H naught if the p-value is less than, it said 0.05 level of significance, 0.05. The test statistic from our formula sheet is T equals B1, which is the sample slope, over the standard error of B1. And now let's take a look back at our regression results. The regression results said, if we come down and look at the slope, this parameter estimate says slope right there. And I'm going to, excuse me. And I'm going to go over here. That was, okay. Slope is, the p-value for the slope is less than 0.0001. It says there really is something going on with the slope. There's a slope that exists, if you will. All right. So let me get out of there and go back to my PowerPoint. So we have found that the p-value is less than 0.0001. So since the p-value, which is less than 0.0001, is less than 0.05, we're going to reject H naught. So conclude that there is a relationship. And if we want to, because we know that the correlation is negative, there is a negative linear relationship between operating margin and number of hotel rooms nearby. Okay, we've got one more slide to go, and that is, we know from the last slide that we can actually make predictions. That makes sense. So let's see what our predictions are, what our equation is, our predictor equation, if you will. Let me go back to StatCrunch, and what we have, I'm not sure why it's highlighted, and I'm not sure how to get it off. Let's see. Let me get on there and see if I can just escape. That doesn't work, so there we go. I'm not sure what I did, but I'm happy that it's gone. Our equation here is given right up here in the results. Operating margin by percent is 70.03 minus 0.008 times the number of hotel rooms. All right, so the first, getting back to my PowerPoint, we have identify the regression equation. So the regression equation, just reading off of the printout, operating margin equals 70.03 minus 0.008 times number of hotel rooms, which I'll call H. Now interpret the slope and y-intercept. In this case, the slope, the y-intercept really does make sense. We've got basically, what does it mean? Remember, y-intercept is the value of y when the x variable, which is h, is 0. So for the y-intercept, the meaning is when there are 0 hotel rooms, nearby. I'm not sure what happened there. Let me get back to my PowerPoint. And okay, we got to come back. Hold on. I'm going to just cancel this and open it back up. Sorry for the delay. All right, and hope I won't make that mistake again. Again, we said here that, let me go back to my pens, that the operating margin equals 70.03 minus 0.008 times the number of hotel rooms. For the y-intercept, that's the value of the operating margin when h is 0. So when there are 0 hotel rooms nearby, essentially when there's no other competition, operating margin is 70.03%. So it's going to be a fairly profitable location. For the slope, and the slope is negative 0.008, and that's going to be the change in the y variable, change in the operating margin, over the change in the x variable, which is change in the number of hotel locations, or hotel rooms nearby. And I'm going to make that into a fraction, put it over 1. Let me look back at the problem really quick and see what the units were. The units were number of hotel rooms, so total number. So it'd be just a hotel room, and operating margin is in percentage. So let me get back to here. So what we've got is, as the number of hotel rooms increases by 1, so for every additional hotel room nearby, near the location, what happens? The operating margin goes down, decreases by 0.008%. So operating margin decreases by 0. This is in percent, 0.008%. And that's the interpretation of the slope.